Hello everyone, thanks a lot for having me today. My name is Nicolas, I'm CEO at Luos. And at Luos we are working on an open source technology called Luos Engine, which is a microservice orchestrator dedicated to real-time distributed embedded systems. I have to admit, I'm not a NuttX guy. I just heard about NuttX a few weeks ago, thanks to Alan. Alan just joined our community a few weeks ago. And Alan, if you are here today, thanks a lot for talking to me about NuttX. And also I want to thank all the organizer of this great NuttX event to choose my talk, to be able to give me the opportunity to make my talk today. So let's start. To begin, I will talk to you about the vision we share with Luos on NuttX. After that, I will talk to you about what Luos is actually and how it's working. And to finish, I will talk to you about what could be the benefits to make Luos work with NuttX. Right now, we are facing a really big challenge because code complexity in embedded systems is rising as hell. And we take 300% over the past decades on the complexity side. But the productivity don't increase so much because we don't have a lot of tools and a lot of framework allowing us to scale this complexity and to manage this complexity. But still, we have some example of products that solve this kind of complexity and give us a result of a really, really agile product. A regular example of it is Tesla. During the Irma hurricane, Tesla was able to update the car batteries to improve the car autonomy, allowing people on the area of this hurricane to flee. Today, customers expect to have this kind of behavior in any product because they have these kind of things on smartphone, website, or any computer application. But this is something extremely difficult to do when you are working on a critical device such as a car. Today, when you only deal with software, you have this agility because now you have like microservice on all the stuff you have on software such as advanced operating system and things like that. And you can develop softwares in a really agile way. And when you are working on this kind of application, to make it agile, you need to have all of the subset of this application to be versatile, loosely coupled, and connected. If you have those three things, you will be able to constantly improve your software over time. Today, hardware is completely driven by software. But devices have hardware specificities. And this is a big problem. And this is a big problem we are solving really well with NuttX and Luos. First, it's extremely difficult to have versatility in embedded systems because we can't have heavy software layers. For example, we can't have any virtualization or something like that, so we don't have Docker. Also, it's extremely difficult to keep things loosely coupling. Because when you develop a device, you have hardware specificities and you will have to design specific piece of software to work with those hardware specificities. And in this case, reusability becomes almost impossible because your code will be highly coupled with the device. And the last one about connection, when you have a complex device with a lot of electronic boards on it, you don't have any default way to exchange information between those boards. This means that the different pieces of software running on both of those boards, on all those boards, don't have any default way to exchange information together. And this completely breaks the agility of the whole design chain, from the embedded side to the cloud or computer application linked to the device. The result is that embedded system engineers spend 75% of their time to remake existing things. That's why we created Luos Engine. Luos Engine is an open source dev tool that makes hardware as agile as software. To solve this problem with Luos, we encapsulate any features. Features can be software, such as any kind of application, the behavior of the device or anything like that. Or features can be hardware, such as, I don't know, a motor, a sensor, a battery, or anything else. And we encapsulate it into a service. A service is a kind of software box. And then we provide an API, a network, a messaging API on top of it. And this makes this feature connected with any other feature anywhere on the complete product. So basically you can have multiple services running on the same electronic board. You can have different services running on different boards, but you can also have applications running on the embedded side, some services running on the embedded side, and some other on the cloud, a computer, mobile app, or anything. And all of those services will be accessible. And as a service developers, you will have you will see all the services as if they were all located in the same place. And this makes development versatile, loosely coupled, and connected. And this completely changes the way you think about hardware product development, because instead of having this really monolithic way to make it where everything will be developed specifically for one product, with Luos, you will be able to develop your product into small, independent, and reusable piece of code that you will be able to compose to create your product step by step and to make it evolve extremely easily. So now it's time to show you how Luos is working. So to do that, I will use those small boards I have here. On this board, those boards have been developed especially for Luos for demonstration purpose. At Luos, we don't sell any hardware, we only develop software. So on this board, we have two boards stacked one on the other one. On the bottom, we have the main one, the main board with a Cortex M0 on it. And on the front, we have two connections, allowing us to add some wires like that and have as many boards we want on the same network. And on the top, we have like different shields, allowing us to have like different sensors or something like that. So together, we will develop a simple connected bike alarm. So this first shield here I have is a motion sensor, an IMU. As I mentioned previously, on Luos, we have two different kind of services. We have application services and driver services, the same way you have those in NuttX. But in Luos, there is absolutely no differences between drivers and applications. Basically, this is like features. This is just, the difference is just how, as a developer, you will develop things in those different services. So in this one, I put only one service, which is a driver, allowing me to access to this motion sensor. So when I put this driver on it, any other services running anywhere on the complete product will have a direct access to this motion sensor. On this one, which is a simple RGB LED shield, I put two services. One, which is a driver, allowing me to access to this physical RGB LED, and another one, which is an application. And this application will make the LED blink when there is a movement on the motion sensor on the other one. It's extremely important for Luos to separate applications from drivers, exactly the same way you are doing it on NuttX, because application can be extremely easily reusable because they don't rely on any hardware. They just use available service drivers of the device. And because you can have drivers everywhere, we have like standardized messaging API on top of it, your application will be able to work on any kind of hardware anywhere on the product without any problem. So to make it work, I have to plug both of those boards together. I will use this wire here. On this wire, we have the power supply and also the network. In this case, we are using RS-485. And I have just to add a power to both of those boards, and now I will plug it and it will start. As you can see, the LED already blink. So when I plug those two boards, Luos makes something we call detection. The detection will be able to list all the available boards on the complete device and to find the physical position of all of them. Basically, we can find the topology of the device. Then, based on this topology, we ask to every node all the services available. And then we create like a small data structure, like a database. We call it a routing table with all the information of all the services available on the complete system. So basically we will have like two nodes with all the services available on them. And then we share this routing table to every node, allowing any service to access any other one as if they were all located in the same place. So now the application running on the RGB LED have a direct access to the motion sensor on the other side. And when I move here, as you can see, the LED just blink. That's great. We have like a really simple red blink alarm or something, but we can't really use it on a bike right now because we can't start or stop it. To be able to start or stop it, I will have to add new features to this system. But I don't want to change anything on this first prototype to add these new features. I want just to add a new features. So to add these new features, I will use another board, which is this one. This one, as you can see, is an ST development board. And I put a button on top of it. And I have the same connections here, allowing me to connect this board to the other network. On this board, I put two services. One, which is a driver, allowing me to access to this physical push button here. And another one that constantly monitors the state of this button and try to find an alarm application currently running on the LED I have here. Try to find this application and start or stop it based on the push of the button. That's it. So to make it work, I can add this board to the device. So this will make it. And when I add this new board, this board here, let me try to make it clear. When I plug this board don't have been detected yet. And because it not have been detected, this board will relaunch a new detection. And this will update the routing table and share this new routing table to all the other one. And now all the other one knows that there is a new board available with this and this and this service available. So as you can see, the alarm is still running. And now when I push this button, as you can see, the LED on white and the alarm just stops. And if I push it again, the alarm runs back. And I can continue to develop my product by adding new features step by step. And when you need to go to industrialization, because you don't want to have like a tons of electronic boards on your final product, you will reshape a lot of things on the electronic side. If you separate applications and drivers as you should do, you will be able to keep the applications exactly the same. The only thing you will have to change are the drivers. Okay, so also, as I mentioned, because as Luos we consider any features like as a connected features to anything, we can natively connect any features developed on any board with like a computer application extremely easily. So let me show you. Right now, Luos is only able to deal with one network. In this case, we are using RS-485. But my computer is not natively compatible with RS-485. So I will have to add another board with an USB connection on it. And on this one, I put two services. One, which is a driver, allowing me to access to this USB serial connection. And another one, which is an application, we call it a gate. And this gate application asks updates to all the other services and convert all the information into a JSON format. Then stream this JSON information through this USB serial connection. And this application can also do it the other way. So get JSON from the computer and translate it into Luos messages. This is something we have right now, the gate thing, and we will get rid of it in the next revision. I will talk to you about it a little bit after that on my presentation. So let me just add this USB connection and show you how it's working on my computer. So is this connected? Yes, I have my USB cable here. Great. So now let's share my screen. So here is a piece of Python code I will use to connect this. I will use this Python code to connect to my electronic device I have here. So let me show you my face, my boards instead. Okay, so I will use this library called Luos. This library is able to connect to a gate and to translate the JSON object sent back by the gate into a Python object. It will be extremely easier for you to use. So the interesting line is this one. On this line, I'm connecting to my USB connection, and I will get back the JSON representing this complete device, and I will create an object called bike, which will have all the features available on this actual device. So when I run this piece of code here, if my Python is working, great. So as you can see, the gate gives me back the routing table I mentioned previously. As you can see, we can have all the nodes where they are on the network with the wires represented on the left here, and we can see all the services available on all of them. Then I can use any features directly as variables into my Python code. For example, here, I just display a 3D bike following the motion sensor I have on my table. So when I move here, as you can see, the bike just follows the movements of my motion sensor. And also, I can do it the other way. Right now, I just get feedback from my sensor, so I can also send order to the device. For example, I can fake a push on the button to the applications that constantly monitor this button and to try to start or stop the alarm. So when I run this piece of code here, I don't know if you can see the LED. Yes, you can. So if I run this piece of code here, this is exactly like someone just pushed on the button, and I can turn the alarm on again like that. And you can do it without having to write one specific line of code on the embedded side, because everything is natively managed by Luos. So that's it about my demonstration. So let me go back to my slides. Great, demo time is over. So now let me resume. So basically the main goal of Luos is to encapsulate features into service. Then with those services, we can create packages we can share with other developers. I don't mention it, but we have that. And also, those packages will be put on nodes. Basically, nodes are microcontroller. You can have your microcontroller on your different board. And then your board will be put on a Luos network, so you can have as many you want. And at the end, you will be able to remote control any features anywhere on your complete device. Of course, we have some minimal requirements. Our library needs at least 30 kilobytes of flash and 2 kilobytes of RAM. Basically, we don't do any kind of memory allocation, so you can just define how many RAM memory you want to give to Luos, and Luos will deal with it. And this technology is completely compatible with bare metal or real-time operating system. And we can deal with any kind of microcontroller from the 8-bit microcontroller to 64 bits without any problem. And right now, this technology only works for half duplex network. And we will work on this thing later. And we developed this technology to be deterministic, real-time compliant, and really suited for cost, size, and industrial constrained applications. And as you've seen on this demonstration, every service have a complete multi-master access to the complete network. So now let me talk to you about some features I can't show you on this demonstration. The first one I want to talk to you about is Object Dictionary. Object Dictionary allow to guarantee the good units of the information sent by your service. For example, if you have one service, which is like an angular sensor, and this angular sensor is working in degree, and you have like an application working in radian, Luos will be able to convert degree from radian and radian from degree on the fly when you ask information from the sensor, for example. Also, we have something we call templates. Templates is a piece of C code allowing you as a developer to define what is the messaging API of a given service type. This is extremely useful if you want to work with another company working on one specific thing. I don't know. For example, if you want to have a specialist companies working on a heavy brushless motor or something like that, you just have to give them this template.c file, and then they will be able to develop the services as they want, and they just will have to access to a data structure you share with them using this template.c, and then Luos will be able to convert Luos messages into this data structure. It's extremely convenient when you work with other companies on your product development. Also, we have something we call a distributed latency-based time synchronization, which is a specific way allowing us to deal with the different time on the complete system. Because to be real time, we need to be able to have a really good timestamp management, and we don't do any clock synchronization between the board at Luos. We only do this distributed latency-based time synchronization. Basically, the idea of this thing is to evaluate the latency between the moment you generate the information and the moment you consume it. And if you have this latency and you are able to send this latency with the message, you will be able to place these events at in the local timeline of the consuming program. So if you want, we have like an article about this specific features explaining everything, and I will share with you the slides, and you will be able to click on it and access this specific features article. Also, we have the possibility to compile Luos as a bootloader, because Luos is able to access to the network and also to the flash. So we just combine both of those capabilities to provide a bootloader, allowing you to flash any firmware of any board of your complete device using the gate thing. Right now, you have to pass through this gate to access your electronic boards, but again, we will get rid of it in next year, I guess. So now let me talk to you about the next Luos Engine main features. We will work on Luos Engine v3. The main goal of this v3 revision will be to allow Luos to work on other kind of network, because right now, as I mentioned, we are mostly compatible with half duplex simple serial communications, and with Luos Engine v3 we will make it work with any kind of network. And the next one, which is extremely interesting, is called multi-fee. Multi-fee is the capability of Luos to be able to switch between multiple networks. So basically, we could have like RS-485 and USB or Wi-Fi somewhere in the network, and Luos will be able to deal with all of those networks, and it will be able to extend the service network to all the networks. So using this, we will not need the gate anymore, because you will be able to have Luos services running on your computer, on the cloud, or anywhere, and those services will be natively connected to all the other services running on your embedded side. So now, what could be the benefits of NuttX and Luos? First, NuttX could use Luos as an extended inter-process communication, because that's what Luos is. This is like an inter-process communication across any kind of small computers or of any kind. NuttX and non-NuttX features could be compatible. What I mean by that is if you have like one board running NuttX on some other boards, like managing some sensors or simple motors or something like that, you may be able to have native connections between the NuttX applications and the bare metal services running using Luos. But there is some advantages on the other side, because right now we have to develop some hardware abstraction layer for each board using Luos, and with NuttX we could support a lot of environments with only one hardware abstraction layer, which could be NuttX. And also, Luos could be used with all the other great NuttX features, because we are not an operating system, so we don't have multitasking on things like that. Luos is just a way to exchange information between the different services you run on the complete product. So, as I mentioned, we have like a hardware abstraction layer, and we want to integrate NuttX through those hardware abstraction layer, allowing Luos to just use NuttX as hardware abstraction. So we will place these NuttX layers on hardware abstraction layer, and after that, any services will be able to use the NuttX features, and you will be able to have like as many tasks you want on one services, and to use all the advanced file system and things like that you have on NuttX. But for that, as I mentioned, we are not expert in NuttX, and this is really new to us, and we need help to make it happen. So any help would be very appreciated, and if you are really interested, please let me know. Thanks a lot, and if you want to have more information, you can go to luos.io, and also we have like Discord where every Luos user is, and we can discuss directly with us. So feel free to reach out. Thank you. Now it's question time.